Hello everyone. On this video we will be looking at the area of a triangle. Okay. Now, different area formulas will be used depending on what type of triangle you have and what information is given to you. Okay, so memorizing just one formula is not always the best way. Sometimes you have different formulas for different circumstances. Okay. Now, if you have just a basic formula where they have given you the base and the height, then you can use the formula for the area equals the base times the height divided by 2, or 1/2 the base times the height, or 1/2 times the base times the height. Okay, and that's once again is if they give you the base and they give you the height. Now, sometimes you'll have a triangle where they will give you the base and the height is just written on the inside here. Okay, so either one of these could be given to you, and then that'll be the formula you use. Okay, so what if you don't know the height? Okay, well, there are different circumstances for that. If you don't know the height, you're going to use this formula when you have an isosceles triangle. Remember, an isosceles triangle is when you have two sides that are the same and the third side is different. Okay, so when you have an isosceles triangle, you're going to use the formula area equals 1/2 times b. Remember, the b is not your base. B is just b, whatever that side happens to be, times the square root of a squared minus b divided by 2 squared. Okay. Now remember, this b is not the base. This b is just a b. We can change this to any other variable. The base is when you use this formula here. So we can say x, and y, and that would be the same thing. But here, it's just a, and b. When you have two of the same sides, those are your a values, and your b is just the side that's different. All right. Now, if you have an equilateral triangle and you want to find the area, and all you know are the sides, then you want to use this formula. You have the area equals square root of 3/4 times a squared. A is just the length of any one of those sides. Just pick one and plug it in. Or if you get square root of 3/4 and turn that into a decimal, it's about 0.433 times a squared. All right. So if you're still writing this, feel free to pause it and finish up, because these are definitely formulas that you want to know. You want to memorize those. Okay. So we're going to go ahead and continue on the next page if you're done writing. And if you only know the length of 3 different sides, now with this formula, you can use this for isosceles triangles. You can use it for the equilateral triangle. You can, but this is mostly used for the scalene triangle because all the sides are different and it's a little more complicated than the others. And again, if you want to use it for the isosceles and equilateral, you can. It's just a little more work. That's why we mainly recommend that you use it for a scalene triangle where all the sides are different. Okay, so when you have the area, that's going to equal S times S minus A times S minus B times S minus C, all that under square root. In this case, your S is going to equal sides A plus B plus C divided by 2. All right, so if you are still writing, by all means, feel free to pause it and finish up. But we're going to go ahead and start on our examples. Okay, so we want to find the area of the following triangles. Remember, the area is just the amount of space on the inside. And if you have to, round it to the nearest tenth. Okay, if it's a whole number, of course, you don't have to do that. But if it's a decimal answer, you want to round it to the nearest tenth. Okay, so A, you have 15 inches. That's the length of there. And you have 18 inches. For B, you have 10 feet, 10 feet, and 5 feet. And for C, you have 22 centimeters for this side, 22 centimeters for this side, and 22 centimeters for this side. Okay, so what I want you to do is go ahead and press pause and solve this one on your own. We'll solve these on your own. All right, so I'm assuming you're all done, so let's go ahead and verify. Okay, we'll start with problem A. And just do a quick redraw of it. So you have 18, a little dotted line, and this is 15. Okay, so we see here just by this triangle that your base is 18 inches. And your height is 15 inches. Okay, now remember, your height can be either inside or it could be outside. You may see some that may show it looking like this, where this would be your 15. This distance is the same as this distance. Okay, so both of these could be your height. Okay, so since we're given the base and the height, we know the area equals 1/2 the base times the height, which is 1/2 times the base, which is 18 inches, times the height, which is 15 inches. Or you can put 15 and 18, doesn't matter. It's multiplication, it's commutative. Okay, so that's going to equal 1/2, or you can put 0.5 times 18 times 15 is 135 square inches, or inches squared. Because remember, inch times inch is square inches. All right, so let's go ahead and do problem B. And I'm just going to redraw it. 10 feet, 10 feet, 5 feet. Okay, so we can see here, because two of the sides are the same length, it's an isosceles triangle. Okay, because it has two equal sides. Okay, so because it's an isosceles triangle, we're going to use the isosceles triangle formula for finding the area. And that's the area equals 1/2 times b times the square root of a squared minus b divided by 2 squared. Okay. Now in this case, remember your isosceles triangle, A, B. In this case, A is equal to 10 and B is equal to 5. Okay, so we go ahead and we replace every B with 5 and every A with 10. Okay, so that's 1/2 times 5 times the square root of A squared, so that's 10 squared, minus B divided by 2, so that's 5 divided by 2 squared. All right, so we know this is going to be 1/2 times 5. We can just make that 5 over 2 if we wanted to. Times the square root of 10 squared, which is 10 times 10, so that's 100 minus 5 divided by 2 squared. They have 5 times 5 is 25 over 2 times 2, which is 4. Okay. Now you could just go ahead and plug it into your calculator here, but I'm going to go ahead and finish up manually. Okay, so we have 5 over 2. So if we make this 100 over 1 and multiply by 4 over 4, we get 400 over 4 minus 25 over 4. Okay, so that gives you 5 over 2 times the square root of 375 over 4. And we're going to go ahead and just plug that into our calculator, and we end up with around 24.2 square feet when we round it to the nearest tenth. All right, so for problem C, and I'm just going to redraw it, where this is 22, 22, and 22. Okay, so we see here we have our equilateral triangle. All sides are equal. Okay, so if you have an equilateral triangle, you're going to use the equilateral triangle formula for finding the area. Okay, so we know that the area is about equal to 0.433 times a squared, or square root of 3 over 4 times a squared, either one. Okay, so we're just going to use this one instead of the square root of 3 over 4, since square root of 3 over 4 is going to give us this anyway, and we're going to round it to the nearest tenth. So since we're going to round it to the nearest tenth, we're just going to use this. Now, if you wanted to round it to nearest 10,000ths, 100,000ths, millionths, then I would use the square root of 3 over 4 a squared, because it gives you a little more precise of an answer. But when you're just rounding to the nearest tenth, this is perfectly okay. All right, so each side is a length of 22, so we know that in this case, A is equal to 22. All right, so we go ahead and plug in our A. So this is going to equal 0.433 times 22 centimeters squared. Okay, so 0.433 times 22 will give us approximately 209.572, and centimeter squared is centimeter squared. And to round that to the nearest tenth, that will give us 209.6 centimeters squared. Oops, there. All right. So, again, if you are still writing, by all means, press pause and finish up. But we're going to go ahead and move on to our next example. Okay. So what if we want to find the area of the following triangles? And we want to round to the nearest tenth if necessary again. Okay, so here you have 5 inches, 6 inches, and 7 inches. And for this triangle, you have 19 centimeters, 12 centimeters, and 25 centimeters. Okay, so I want you to press pause and find the formula that would best give you the area of these triangles. All right. So assuming you've pressed pause and already worked this one out, so let's go ahead and verify. Okay, so we see here we have all different lengths of the sides. Okay, so we pretty much know we're going to use Hero's formula. Okay. So we know that for this one, we can let A equals 5, A equals 6, A equals 7. Doesn't matter, they're all different. But we let A equals 5, B equals 6, and C equals 7. And again, if you want to make A equals 6, B equals 7, and C equals 5, you can. It will give you the exact same answer. This just happens to be the order I picked. Okay, so for Hero's formula, first we have to find S. So we know that S is equal to, what I'll do is I'll draw a little line through my S since we have a 5 in here, and I don't want anyone mistaking the S for a 5. So the S equals A plus B plus C divided by 2. So that's 5 plus 6 plus 7 divided by 2. Okay, so that gives us 18 divided by 2, which is 9. So we know that S is going to equal 9. Okay, so now that we have this, we can apply it to our formula. So A is equal to the square root of S times S minus A times S minus B times S minus C. Okay, so we go ahead and replace the S with 9, the A with 5, the B with 6, and the C's with 7. So that's going to equal the square root of S, which is 9, times S minus A, so that's 9 minus 5, times S minus B, so that's 9 minus 6, times S minus C, which is 9 minus 7. Okay, so that's going to equal, I'm just going to take it to the right instead of below because I want to leave room for the second one. So that's going to equal the square root of 9 times 9 minus 5, which is 4, times 9 minus 6, which is 3, times 9 minus 7, which is 2. All right. So 9 times 4 times 3 times 2 is 216. So you have the square root of 216, which is approximately equal to 14.7 square inches. Okay, so that's the area inside of this triangle. All right, so let's go ahead and solve problem B. Okay, so I'm going to go ahead and redraw it. There and there. So we have 19, 12, and 25 centimeters. Okay, so we can let A equals 19, B equal 12, and C equal 25. Okay, so we know that our S, we always have to solve for our S first because that's kind of the backbone of Hero's formula or Huron's formula. So S is going to equal A plus B plus C divided by 2. Let me kind of separate this a little bit. So that's going to equal 19 plus 12 plus 25 divided by 2. So that's 56 divided by 2, which is 28. Okay, so we know that S is going to equal 28. Okay, so now that we have our A, our B, our C, and our S, we can go ahead and plug it in. So we get our formula. A equals the square root of S times S minus A, S minus B, times S minus C. Okay, so we go ahead and plug those in. We have the square root of S, which is 28, times S minus A, so 28 minus 19, times S minus B, So 28 minus 12 times S minus C, which is 28 minus 25. Okay, let me go ahead and simplify it. We have our 28 there times 28 minus 19, which is 9, times 28 minus 12, which is 16, times 28 minus 25, which is 3. Okay, so you multiply all four of those together, you will get the square root of 12,096. Okay, plug that into your calculator. You get around 109.98 centimeters squared. And if you round that to the nearest tenth, you get 110 centimeters squared, which is your rounded answer. All right. So hopefully everything here made sense, and I will see you on the next video.